So 4 is 4 was a confusing one. I did not put a lot of weight on this because we did not spend a whole lot of time talking about it. I will say first of all that I considered C and E to be highly proficient. So if you got these ones correct, then good job. But A, B, and D we talked about and we had specific notes on. I said you could simplify these if you needed to. Some students just took a clean look at this and said there's no way to solve this because 3x is smaller than 4x and 6 is smaller than 12. But if you were to actually take a little bit of time to solve it, that's a little bit misleading. And if I was going to solve this, I would remove some balance sets. And then I would have 3x minus 3x is 0, so I'd have 6 on this side equals 4x minus 3x, which is x, plus 12 on the other side. And then if I continued to simplify, I would remove a balance set. I would remove another balance set. And then by the time I'm done with that, I would have 6 minus 12 is negative 6. And on the other side, I would have x. That is a solution. We have number equals variable. So that means that this is 1. This has one solution. So when you see a situation where the variable and the number are both larger on one side than they are on the other, the coefficient and the constant are both larger on one side like this, it means that your answer, your value for x is it doesn't necessarily mean that there's no solution, but if there is a solution, it's going to be negative. Okay? So this is negative because this number has to get smaller, has to be further down in order to add 12 and have it be the same as this one. Okay, moving on to the next one. Most students got that first one correct. Most students got the second one correct as well. The second one, you can just tell by looking right here that 3x plus 6 is the same as 6 plus 3x. But you can also, if you use the commutative property, you could switch them around and have 3x plus 6 equals 3x plus 6. But just about everybody spotted that these were the same and correctly identified that that means that because these are identical expressions, that all numbers are solutions. Okay. I'm going to go over D next because it was not HP, but this one was another one where students could figure this out pretty quickly. Some people thought these were exactly the same, but if you just start by doing keep, change, change, you will see that this is 3x plus negative 6. And we talked about how when the variables are identical but the constants are not, there is no way this can be true. It doesn't matter what 3x is. Adding 6 is never going to be the same as adding negative 6. So because these variables are exactly the same and these numbers are different, this is not possible. If you did some simplifying moves, you would find that out. Like if I added 6 to get rid of this negative, this would become 3x. And on the other side, if I would have to also add 6, this would become 3x plus 12. There is no number that you can add 12 to and still come up with the same number. If I simplified further, subtracting 3x and subtracting 3x from both sides, I would get 12 on one side and 0 on the other. There is no value for x that will make 12 equal to 0, so this is not possible. So this equation has no solution. There is no value for x that would make that true. Now these ones, most people said these were no solution. We did not talk about these examples, which is why I considered them to be highly proficient. So the bottom one here, we have 3x equals x. You know what? I'm going to go in order. C says negative 3x plus 6 is equal to 3x plus 6. Most students saw this negative and thought there's no way that negative 3x can equal positive 3x. Now that is almost true, but there is actually one number where that can happen. And we can find it by doing this. If I was simplifying it, I would remove balance sets, so I might get rid of those 6's first, and I would have negative 3x equals 3x plus, negative 3x equals 3x and not plus anything. And then my next step would be to, let's remove another balance set. I want to get rid of all of the x's on one side. I don't care which side, but let's get rid of them on the negative side. I usually like to get rid of negatives if I can. So I'm going to add 3x to negative 3x to get 0 on one side, but then I have to add 3x to get 0, or to get 6x on the other. So 0 equals 6 times a number. What number can I multiply by 6 to get 0? Well, a little bit more math. If I need to get rid of that 6, I can divide by 6 and divide by 6. 0 divided by 6 equals 0, and 6x divided by 6 equals 1x. So if x was 0, these would be the same. Negative 3 times 0 is 0 plus 6. Positive 3 times 0 is 0 plus 6. Those are both the same. So this one, most students thought it was no solution, but this one was one solution. And then the last problem was the same thing. 3 times a number equals the same number. A lot of students said, well, that's not possible. However, if I was to simplify this one, I could get rid of a balance set. I can remove an x from both sides. And again, I would get 2x equals 0. And if I get 2x equals 0 here, then 2 times the number equals 0, I would just divide by 2. I would divide by 2, and I would get x equals 0 divided by 2, which is still 0. So this one also was one solution. There is only one number that can make this true, but there is a number. So that tricky 0 got us for a few of these. So 12 cannot equal 0, but x can equal 0, and so both of these had one solution.